Now let's talk about the influence of the soil resistance to the high-strength dynamic test data. In the previous slides, we have discussed that about the proportionality. F and V, they should meet each other before the end of the pile. Before the end of the pile. But usually after the first peak, F and V, they will separate. And that is because of the influence of the soil resistance. So now let's discuss how this soil resistance cause the force and V, they separate. Let's say there is only one soil resistance, Ri, at the location of Xi. And when the input force travels to the location of Xi, it will meet the soil resistance. So let's cut the pile at the location X into two parts. For the upper parts of the pile, the soil resistance will stop the pile from going down, right? So that means there will be a compression force traveling up in the upper part of the pile with the value of half Ri. So compression force is positive, right? So the force curve will move up with the value of half Ri at this location because the compression force is positive. And also, a traveling compression wave will generate a negative velocity, right? According to the sign relationship in wave up and wave down. We know that in wave up, force and velocity, they have opposite sign. So this compression force will generate a negative velocity. And the velocity times impedance Z will get a value of minus half Ri, right? So the velocity curve will move down with a value of half Ri because the velocity is negative. So that causes the F and V curve, they separate with the distance of Ri. This is how the soil resistance works during the force traveling down in the pile.